Alright, let's build something. In this video, I'm going to start building a real feature using Nexus. Right now, this project is intentionally bare bones. I have already run Nexus init and Nexus product context commands on it. I will have videos covering them, so I won't repeat them here. Instead, let me actually run the project, and you'll see exactly what we have today, which is clean, boring, boilerplate app generated by standard generators. Now, the first feature I want to add is the main application UI. I'm calling this feature the layout. We start simple, create a features folder, inside that a layout folder, and inside that a readme.md. That readme is important because this is where the feature comes to life. Now, normally at this point, you'd have a UX designer or a product manager mock out the application. And yes, you could use the Nexus product manager agent to do that for you. But this is a pretty generic task. So instead, I'm switching to ChatGPT to preserve my Claude Code tokens for the real work. I'm not going to walk through the prompt or the full spec I got back. That's not the focus of this video. If you are curious, you can find the final prompt in the Ripple's project GitHub repo. At a high level, the spec covers navigation choices, color schemes, desktop and mobile layouts, and other guidelines for the UI. Once that spec is in place, the next step is critical. We convert it into engineering epics. For that, I'm going to use the epic command. All you need to do is pass in the readme as the argument. You'll notice the agent immediately does a mandatory right-sizing assessment. This part matters. The goal is to implement work in increments that are easy to understand and easy to review. Here's how we think about it. If an experienced engineer can deliver an increment within a single sprint, that's the right level of complexity, because when someone works on something for a sprint, they don't just come back with lines of code. They come back with assumptions, decisions, trade-offs, and a lot of context that never fully shows up in the code itself. When you review that work, you're applying judgment across all of those dimensions. That's why we want to keep incremental complexity manageable. And sure enough, the agent comes back and says, "This is a bit too much." It explains why and gives you options. Option 1 is great if you want to defer some functionality to a later phase. Option 3 is for people who enjoy living dangerously. In this case, I'm choosing option 2 because I want the full functionality described in the spec. Now let's sit back and wait for Claude to decompose the requirements into right-sized epics. And there it is. The agent has broken down the requirement into 4 epics that have clear separation of concerns. At this point, we can decide to implement the functionality that delivers immediate value to the user without being bogged down in validating, implementing, and testing functionality that can be deferred to later. This is where you go back to the product owner and validate the scope and priorities. Once everyone's aligned, we can move on to the next steps. Upon review, we can see that it's sufficient to stop with just the first 2 epics, as that would give us a sufficient application layout to go build out real user functionality. Thinking in Agile, you want to deliver features that address actual jobs to be done for the user. A problem we are addressing with Nexus is exactly this grounding. It's very easy to let your AI run wild at all the bells and whistles and get distracted from delivering real value to customers. Let's focus on the first epic. Once it's reviewed and everyone's happy with the scope, run the HLD command to generate a high-level design for this epic. This command uses an architect agent to not only make technical design decisions, but also to push back on the scope. Since we have already right-sized the epics, this step should go smoothly. When you get back the high-level design, review it carefully to make sure it is making the right technology choices. Do not just assume it is correct because it sounds reasonable. For example, I noticed that it was trying to use ShardCN with Redux UI. It is January 2026. Base UI is not yet mainstream. Claude has likely seen far more Redux UI usage than Base UI. So statistically, it will lean that direction. I want to challenge that. So I'm going to ask Claude to consider using Base UI instead. Let us see what it comes back with. For some reason, it is claiming that Base UI would require manual Tailwind integration, and that I would need to create something like a sidebar from scratch. That cannot be right. It looks like I either asked the wrong question or I did not give Claude enough context to make a fair comparison. So, let me try again. Now Claude wants to use Base UI. Good, let's go with it. And Claude will update the high-level design with that choice. Once it is done, let's verify that it actually picked ShardCN with Base UI. Do not assume. Check the document. Okay, good. Let's take a second to appreciate that it also generated a mermaid diagram for us. Also, Claude needed a few clarifications, but notice that it already came up with reasonable defaults, which means it did not have to stop and wait for me before progressing the design. Let's tell Claude that those defaults look good and bake them in as the actual values. There's something else that I don't quite like. Claude used React context to persist the sidebar state, whether it's expanded or collapsed. Which is correct, but I'd have used a state manager like Jotai for this instead. But to be fair, the architect didn't know whether it was okay to add a new dependency for something it can natively do, and in most cases, we would not want that either. Let's tell Claude that we want to use Jotai for state management. The updated HLD now uses Jotai. Let's review the rest and make sure there are no other concerns. We could have avoided that back and forth drama around ShardCN and Jotai by including them in the stack.md before we started the HLD. Let's do that now. As a result of the updated design, we have a few additional dependencies to add. Let's go ahead and install them. Now everything is ready to break the design into executable tasks. We do that with the Nexus task command. I am also going to tell Claude that the dependencies are already installed, so it can skip checking for them. Claude is saying it did not find the task template and task labels files, so it will proceed with its own. That might be fine, but we do have sample templates in the Nexus repository. So instead of letting it improvise, let's pull those in and keep things aligned. In the Nexus repository, these are the sample files we want to use. Instead of copying them manually, let's use the utility script that already exists in the repo. First, get the raw URL of that script. Then go back to the terminal. Make sure you are at the root of the project. Now use curl to download the script. Once it is downloaded, give it execution permissions. Then run the script, passing the relative path of the files we need. And just like that, we now have the task template and the task labels in place. Now we need to set the document root according to our GitHub repository. This allows the agents to generate absolute paths when referencing documents in the repo. You can also open the task labels and the task template at this point. If you want to customize naming, structure, or metadata, this is the right time to do it. Alright, let's retry the Nexus task command. It is worth understanding what actually happens when we run this. The task command is not a single agent. It is a coordinated multi-agent workflow. First, a decomposer agent breaks the high-level design into discrete tasks. Each task is scoped and bounded. Then an architect agent performs low-level design on each task. This is where implementation intent becomes concrete. Finally, an analyzer agent reviews the tasks and their designs. It checks for consistency, missing specifications, and structural gaps. So what we are triggering here is not simple task generation. We are running an internal design validation pipeline. Once the pipeline completes, it asks you to review the tasks it generated. You also get a summary of the analysis. It highlights any concerns and tells you where to find the full report. When we continue, the workflow creates the GitHub issues under an epic that matches the one we are currently implementing. The final task.md file includes links to every issue it created. Let's do a full review of the tasks that Nexus created. Don't worry. These are all bite-sized chunks that you should be able to understand within a few minutes. One thing you'd notice as you go through the task files is the Git workspace section. This is the Git worktree setup that Nexus will use if you use it to implement these tasks. Alright, I'm ready for implementation. I have the option of going through each task and implementing them individually. For that, I'd use the Nexus dev command and pass the GitHub issue number. The agent starts off by pulling the issue from GitHub and scanning for the worktree information. It sees that it's currently on the main branch and proceeds to set up the worktree. After creating the worktree, the agent asks whether you want to copy untracked files, such as .env files, into the new work tree. This is often necessary to ensure tests run correctly in the new branch. I'm going to say yes. Once it finishes implementing the changes, it comes back and asks you to verify the implementation before making a Git commit. After I've done a code review, I'll approve the commit. Nexus then commits the code and closes the GitHub task with a comment and a link to the commit. The comment it posts outlines what was implemented and which of the acceptance criteria that it was able to hit. We are also going to keep the work tree since we'll be working on the remaining tasks. Once you've gone through the proper steps to generate the task definitions and review them both individually and with your team, there's no longer any need to babysit Claude while it writes the code for you. Nexus gives you the YOLO command because of this reason. YOLO is not a / command. It is a script that you run directly from the terminal. That script then in turn loops through all the tasks you assigned it and execute them via Claude Code agents. Here, we are giving it tasks 9 to 12, which are the remaining GitHub issues from the epic. Note that in both YOLO mode and dev mode, Nexus uses a test-first development approach. So it first analyzes the design for the tests, writes them, and then uses those tests to ground the implementation of the design. Because Nexus is not only writing tests and code and compiling, but also running the entire test suite, this can take some time to complete. I'm going to jump ahead to the end and show you what I got. Nexus is now done with all 4 tasks. We are up to issue number 12. You can see the summary here, including the test results and the coverage report. It does complain about one thing. It was not able to run the end-to-end tests. That is because I did not set that environment up. And it does not have the privileges to provision that on its own. That is on me for not setting that up. Before we move on, let's make sure all tasks are actually closed. Go through the list. Check the statuses. Make sure nothing is left hanging. Everything looks good. So now let's switch to the work tree and actually run the project. This is the moment of truth. Let's see if this actually works. Builds and runs without an issue. And here we have it. The layout that the agents built for us. Navigation works fine. Sidebar works as expected. No surprises. This was a very simple sample. Just enough to validate the flow, generate the epic, produce the high-level design, break it into tasks, and let Nexus execute. From design to working app. I'll post a few more videos as I go through more complex features of Nexus. But for now, this proves the loop works. Now that we are happy with the outcome, it is time to close and clean up the docs. When we ran the Nexus task command, it created a task folder. That folder contains the files that were used to generate the GitHub issues. Those files serve their purpose. Now that the issues are closed, they are no longer useful. This is where the close command comes in. It cleans up the task files. And it also removes the work tree that was used for implementation. In their place, it generates a post-implementation report. This becomes the permanent artifact, a record of what was built, what decisions were made, and what the outcome was. Once it gets your approval, it will go ahead and delete the unnecessary files and remove the work tree. The repository is clean again. Design artifacts are preserved. Temporary execution scaffolding is gone. So that is it. If this workflow resonates with you, check out the repository. Run through the toolchain yourself. Try it on a small feature in your own project. See how it feels to move from scope design to working code in a disciplined loop. And then push it further. And of course, like and subscribe to stay in the loop.